All right, today we are going to tackle a skill that is absolutely essential. We're talking about how to look at any chart, any graph, any table, and pull out a conclusion that is 100% provable. Let's dive in.
So what's the biggest mistake people make when they're facing these questions? You know the feeling, right? You're stuck, you've narrowed it down to two choices, and they both sound kind of right. That is the classic trap. And today, we're going to make sure you never fall into it again. The solution, you'll be happy to hear, is actually pretty simple. It all comes down to a powerful shift in your mindset. Think of it as a golden rule that is going to change everything about how you approach data.
Okay, so this slide gets right to the heart of it. See, our brains are hardwired to answer the question on the left. What do I think is happening? We naturally try to infer things, to connect the dots using our outside knowledge. But that's not the game we're playing. The test is asking a much, much stricter question. What can you literally prove from the data in front of you?
This is it. This is the question you need to burn into your brain. It is not about your intuition. It's not about what seems logical or likely. It is all about cold, hard proof that you can find only within the four corners of the information they give you.
And here's the practical application of that rule. Your new best friend is your own finger. For every single answer choice you have to ask, can I physically point to the evidence in this chart that proves this statement? If the answer is no, it doesn't matter how smart it sounds, it's wrong. Period.
Okay, so before we can start proving things, we have to get the lay of the land. We need to understand the basic structure of the experiment. And really, it all just breaks down into three essential pillars.
And this is how simple it is. You just have to ask yourself three little questions. First, what did the scientists change on purpose? That's your independent variable. Second, what did they measure to see what happened? That's your dependent variable. And third, what do they have to keep the same for it to be a fair test? Yep, those are your controls. Answer these three and you've got it. You understand the experiment.
Now that we've got the setup down, let's get really clear on what a valid conclusion actually is. Because in this world, it has a very specific definition. These are the rules of the game.
So any correct answer has to pass this three-point inspection. Number one, it is based only on the data they gave you. Number two, it is supported by evidence you can physically point to. And number three, it follows logically from the main pattern or trend you see in the data. If an answer fails even one of these checks, it's out.
I cannot stress this enough. This is the hardest habit for us to break. You might be a total genius in biology, but if the graph doesn't show it, you have to pretend you don't know it. This isn't a test of what's in your head, it's a test of what's on the page. No outside knowledge.
Okay, let's get practical. You're staring at a brand new graph. What's your very first move? It is not reading those long, confusing answer choices. Nope. Your first move is to find the main relationship, the story, the trend in the data itself.
And don't overcomplicate it. Your one and only mission at this stage is to describe what that graph is showing in a single, simple sentence. You're basically writing the caption for the graph inside your head before you do anything else.
And here is the magic formula for writing that sentence. Just look at the x-axis, the one on the bottom. Ask yourself, as this thing increases, what happens to the stuff on the y-axis, the vertical one? Does it go up? Does it go down? Does it just stay the same? That's the whole question.
And what you'll end up with is a perfect little sentence like this one. Simple, direct, and totally provable just by looking at the graph. As x goes up, y goes up. Once you have that sentence in your head, all you have to do is find the answer choice that says the same thing, even if it uses slightly different words.
So let's wrap this all up. What is the big, evidence-based idea that you need to walk away with?
It all comes down to clarity. It's about flipping a switch in your brain, turning off the guesser and turning on the prover. Your entire argument for an answer has to live inside that little box on the page. If you find yourself having to take even one step outside of that data to justify your answer, you're going down the wrong path.
So I'll leave you with this thought. And honestly, this skill goes way beyond just taking a test. The next time you see a chart in a news article or a graph in a work presentation, how are you going to use this rule? How are you going to challenge yourself to ask that simple, powerful question? What can I actually prove here? Trust me, that little shift changes everything.